Question number 22. Charge flows through a liquid. The charge flow is made up of positive and negative ions. Let me assume positive ions and negative ions, plus Q and minus Q. Okay. In 1 second, 0.10 coulomb of negative charge flows in one direction and 0.1 coulomb of positive charge flows in the opposite direction. If I assume this 0.1 coulomb flows in this direction, minus 0.1 coulomb flows in this direction, what is the magnitude of the electric current flowing through the liquid? Now, what do we do? What is electric current? Electric current is nothing but flow of positive charges, right? So which means what I will do, I will consider that 0.1 coulomb flows in 1 second in this direction, positive charges are flowing like this. So which means this will amount to 0.1 amperes over here. Now when I say minus 0.1 coulomb is flowing like this, which is also equal to 0.1 coulomb per second flowing in the same direction, in the opposite direction, positive charges, right, which is 0.1 ampere. Here also the sum of these two will be equal to 0.2 amperes. Okay, I hope you understand this question. Many people had got this incorrectly and they think it is 0. Okay, I'll explain it. If you want, I can elaborate it a little bit more. For example, if you are moving in a car, okay, and you see the positive trees, the trees are seen to be moving in one direction while the car is moving in the opposite direction. While the car is moving in this direction, you observe trees are moving in this direction. Okay, so this is your negatively charged charges. These are the negative charges which is moving in this, but the positive charges are moving like this over here. Okay, so the trees are observed to be moving. So it appears when the electrons are moving like this, it appears positive charges are moving in the opposite direction. So this will contribute to the positive electric current. And if you consider these positive charges, let me assume that there is a conveyor belt or something which is being kept over here and the trees are already moving like this. Okay, so in that case what happens? This will also add up to the current. Or you can also say something like you have one car coming like this, you have another car coming like this over here, and as a result of this, forgive me, okay, so you have a car moving like this. So as a result of this, so if this velocity is 30 km per hour and this is 30 km per hour, what do you observe? As observed from here, it will be, you can observe that this car will be moving at a speed of 60 km per hour according to you, right? The same concept has been applied over here. Okay, let us move on to the next one.